Continuing education knows that at the end, students want to graduate, and we can help them do that because we take the time to really listen to their needs, and we understand all the different options that are available across the campus for them.
We don't take a cookie cutter approach. We realize each student comes with their own story. So whether it's a part-time student looking to complete a degree program or someone just looking for online courses, we're there to connect them to the resources of the university.
Good afternoon. My name is Jan Burton. I'm a local arts activist, the chair of the Conference on World Affairs Board, a Hauser, and a general CWA lover, like many of you. For recording purposes, today is Thursday, April 10th, 2025. It's 2:00 p.m., and this is panel number 18103, titled The Music of the Sun, Moon, and Stars. Thank you for joining us. Before we get started, the University of Colorado Boulder, Colorado's Flagstaff University, honors and recognizes the many contributions of indigenous peoples in our state. CU Boulder acknowledges that it is located on the traditional territories and ancestral homelands of the Cheyenne, Arapaho, Ute, and many other Native American nations. Their forced removal from these territories has caused devastating and lasting impacts. While the University of Colorado Boulder can never undo or rectify the devastation wrought on indigenous peoples, we commit to improving and enhancing engagement with indigenous peoples and issues locally and globally. We will do this by recognizing and amplifying the voices of indigenous CU Boulder students, staff, and faculty and their work, by educating, conducting research, supporting student success, and integrating indigenous knowledge, and by consulting, engaging, and working collaboratively with tribal nations to enhance our ability to provide access and culturally sensitive support, and to recruit, retain, and graduate Native American students in a climate that is inclusive and respectful. One thing I'd like to mention is that we want to make sure that you have a chance to ask questions. So for the first 30 minutes or so, we will be riffing off of each other. I know that these great panelists have brought their thoughts on the subject, the quite unusual subject, by the way. And, but you have a chance to ask questions. So if you want to ask a question, raise your hand, and one of our producers who are standing around the room will bring you a card. And when you fill it out, if you're a student, please say that you're a student because we give priority to you for questions. And also, please write legibly. And now I'd like to introduce our panelists. On the very end, against that way, is Jean Hertzberg. Dr. Hertzberg is currently a professor of mechanical engineering at CU Boulder. She has pioneered a spectacular course on the art and physics of flow visualization and has completed a textbook to support the course. She has developed another art and science course, The Aesthetics of Design, a mashup of studio art course, industrial design, and engineering project courses. Current projects include study of the aerodynamics of musical woodwind instruments. I learned about Dr. Hertzberg during COVID because I am associated with the College of Music, and at the time, you remember during COVID, they were shut down. They could not play instruments. And what this infamous mechanical engineering professor did was a study about the flow of aerosols and the difference between different musical instruments and as well as the voice as a musical instrument. And I remember tracking that study and getting the results of it I got it through a sneaky way, I guess, because I was very fascinated with what the result was going to be. And as I remember, it was the voice and the oboe that were the most, but you can comment on that.
Actually, it was the clarinet, which turned out to be a heavy producer. But the real outcome of the study was that masks work, even on trumpets and on the end of the oboe and on humans. And it really didn't affect the playing of the instrument significantly, especially young people who are just learning to play anyways. Some of the professionals were a little pissed off at the slight variation in feel that they got from having a mask on their instrument, but it really worked to make instruments safe to play.
So very cool kind of mashup of mechanical engineering and music. And I really never got the association until this. Next to her is Shania Jarrett. Shania is a PhD candidate in astronomy and astrophysics at the University of Maryland, specializing in the application of machine learning to study gravitational waves. She got her undergraduate degree from CU Boulder, and her research spans binary black hole mergers observed by LISA, space instrumentation, and solar wind irregularities. Next to her is Eli Hans, an entrepreneur, transformational theater coach, motivational workshop leader, award-winning stage actor and playwright, theater producer, director, composer, and singer. He does it all. Last year, he performed the award-winning Out of the Blue theater production of his life story at the Dairy after the CMF, and has won awards for that from Hollywood. He joins us from Mexico, so thanks for coming. Mm-hmm. And then next to me is Seth Schaefer, who is a composer and researcher whose work hybridizes technology, new media, and art and science, with a specific focus on real-time notation, interactive music, and algorithmic art. Seth is an assistant professor of music at Cal State San Marco and is a composer and performer. His artistic practice represents musical exploration at the extreme edge of performance. And I think because, and the description of this, which was created by students, by the way, is exploring the surprising intersection between astronomy and music. And I'm going to ask Seth if he would please kick it off with some thoughts.
Great. Thank you so much. And since this is my last panel, just thank you so much to CWA, all the organizers, the moderators, the students, my host family while I'm here. It's just been a fantastic experience. So I thought it might be, I'll set some context that I know about this subject, which is from a classical musical background. And so much of Western philosophical history connects the cosmos to sound and music. From Pythagoras' Music of the Spheres, which is the idea that planetary motion is somehow connected to musical intervals, to Plato's Timaeus, where the soul of the world was created using harmonic ratios, to Boethius's Music Mundana, or music of the cosmos, which describes the orderliness we see in nature as relating to musical scales. I've been fortunate to collaborate with real scientists. I'm not a scientist, although I may say scientific things today. For the scientists on the panel, please correct me if I say something stupid. So I've been able to connect with real scientists who study astronomical objects and to take their measured data and turn that into audible sound. This is a process that's often called data sonification. Two of the projects that are, I think, most relevant for the panel are, the first one involved images from a star field collected at the South Pole with about 800,000 objects in its view, all within the large Magellanic Cloud, observed through this a robotic telescope during the 4-month-long winter in Antarctica. And then the other project involved measurements of vibrations of the sun and turning that into audible sound. So I'm really happy to talk about both of those projects in more detail or try to relate them to our discussion as it goes on. But as I reflect on this, some things kind of emerge beyond the specifics that I could share. I think that maybe some potential things we can talk about could be the collaborative process between scientists and artists, the very intricate mapping that must take place between the data that is collected and then resulting sonifications of that data. I think something maybe of interest to you all, very engaged citizens, which is this role of the citizen scientist and what important role that they play in this whole process. Empowering our senses other than our eyes and our brains, empowering our senses to understand our world around us. And lastly, like art as a necessary component to scientific discovery. So yeah, thank you. I'm looking forward to our discussion.
Anyone like to go next?
We're going in a row?
It doesn't really matter.
Sure. Hello, everyone. Thank you for being here. So when I saw the title of this panel, at first I thought, oh my gosh, what do I have to contribute to this? And I sat with it for a while, and a few things came up. And one of them is, Shania and I were having a conversation a couple days ago. She said, I hope that in my lifetime I get to know if there's life on other planets. And I just want to tell you, there is, because I'm from another planet. So, nice to meet you. Has anybody out there ever felt like you're from another planet, having a hard time adjusting to this one? So, when I saw E.T., I cried from a very deep place because I knew that movie was about me. I'm still waiting for my parents to come and find me and take me home someday. So, no, where I really went with this is that I was very fortunate when I was growing up in Mexico City. I was raised in Mexico City. My dad and my mom were very involved in our lives, and I very clearly remember when I was about 7, we had a house in the mountains, and we used to go every weekend. I remember the moment when my dad took out his telescope to teach me about the stars. And more than what I was learning, it was about the moment of being with my dad during that very special time, the focus he gave me and his need to connect with me about that. So I learned about Orion's belt and Ursa Major and all those things, the tilted pan. And the other thing that connects them is that my dad also taught me to play the piano. I grew up in a musical family, and the moments where I sat next to my dad playing duets with him on the piano were just as special as when he took time to tell me about the stars. So for me, that's where I went with this, and where the connection begins for me, from the healing and the peace and the joy and the love that comes from gazing at the stars, that also comes from music. I used to fall asleep under the piano as my mom played. She was a concert pianist, and I used to just fall asleep under the grand piano. And then years later, when it was my turn to learn, I could sit at the piano and almost play note by note what I had been hearing for years. So I have a very deep connection to music. And so I'm hoping that we'll be able to explore a little bit, aside from what you brought up, some of the healing aspects and the expansiveness of music, and how that might relate to how we feel when we gaze at the stars.
That's cool.
Hello. Can you hear me okay?
No.
So? Okay, I'll try to speak a little more loudly in my microphone. But when I think about science and music, I always come at it from more of a technical perspective. And earlier Seth was talking about data sonification and turning data into music. But then I wanted to think more about how these two topics that are unrelated are similar in a lot of ways, and how they have a lot of parallels. And I think while they seem very different, there's a lot of ways in which they are similar. And so science to me is organized data. We study it, we gain knowledge from it. It tends to be abstract and objective. But with music, this is organized sound, and we create it to connect with our feelings and our memories. And it can be abstract at times, but it usually elicits some type of emotional response. And I think, especially in astronomy and astrophysics, we only really interact with this field with our eyes for the most part. So we don't really hear from space. We can't smell it. We can't taste it. We can't hold these very massive objects. You burn your hand, you know. But I think with music, we use primarily our ears. we can feel the vibrations, we can hold the instruments, but we can't necessarily see the music outside of the notes, and we can't taste the music either. So I think while it seems like we don't need to use all of our senses, that we could still be engaged in these life experiences from kind of an emotional and intellectual standpoint. And I guess I would also say they both reward you for being curious, and they reward you for your practice and your effort. They reward you for being creative. And so I think in both cases, they kind of free our imaginations in some way that we can move past something that doesn't just limit our senses.
Nice.
I got the advantage of going last. So much of what you all said really resonated with me. I've spent a long time on the border, the intersection between art and science, and between music and visual art as well. So I kind of feel like, you know, a representative of the visual artist here. So I feel like I'm an artist, and I believe all humans have the capacity to be artists, just like all humans have the capacity to be scientists. And I'm all about trying to blur the boundaries between these two fields that sometimes feel like they're in opposition, but in reality, there's so much synthesis, like you were saying, so many commonalities between the two fields. I teach engineering students. I teach them art in the context of an engineering class, and I'm always blown away with the amazing creativity that they exhibit and the new knowledge they actually bring because of their creativity. So my discipline is fluid mechanics. Okay, fluid mechanics is the science of gases and liquids, and you know it's throughout. I mean, we are all walking bags of water at the bottom of this ocean of air, okay? And so we're all very intimate with a lot of the physics of gases and liquids. Engineering is about knowing the governing physics and properties and equations and doing the math to make gases and liquids obey our will. And so a lot of my field has been driven by military and industrial applications. And so we know a lot about the math, the engineering of things with those kind of applications. But my students in my flow visualization class, where they're making images, beautiful, amazing images of gases and liquids, they use things out of their kitchens and in their bathrooms, and they take pictures of the clouds in the sky, and we look at both the artistic aspects of that and the emotional impact it has, and the science of why does it look like that? What are we actually seeing? And so the more you know about it, the more beautiful it becomes. And that's something I want for all my students in all my classes. It's actually Feynman who tells his story of how he sees a flower, and Feynman is a famous physicist who is renowned for his teaching as well as his physics. So he sees a flower, and his artist friend says, "Oh, you see this flower and you dissect it, and the knowledge just makes it dry and meaningless." But Feynman says, no, the more I know about what's going on in that flower, you know, in the Fibonacci series that guides how the seeds form in a sunflower, and the physics that make the petals yellow instead of blue or green, the more I know, the more beautiful and meaningful it becomes. And that's what I want for all of my classes and for all of my students, both my art students, and I do get a few in class, and the engineers.
Nice.
Thanks. You have a question?
Seth, I saw you taking a lot of notes. Is there anything that you want to amplify on from previous comments?
Well, first, I mean, the fantastic views of the same subject. I think that's what's so interesting about the CWA is that all four of us have a very different take on this, and I think that's the synergy in that is super amazing. Yeah, I think Shania, I just love the connections that you drew. I think that's there's so much that resonates about that. One thing I might push back or like ask you about, because you said that both science and art or music kind of are predicated on organization. But I think I can think of many examples of music where that organization, it tests our threshold of understanding organization. I'm sure that in my limited understanding of like the cosmos, some of those early Western philosophers, Pythagoras, Plato, etc., while they desperately wanted to see something like integer ratios of periodicity of the the planets or something like that, like they weren't right? So like there's we want to see that. We want to see the organization. I think that's probably like the Gestalt mindset that we as humans we're so desperate to see patterns. So I just wonder if maybe you could speak a bit to like the disorganization of science a bit. And I don't know if that has any bearing on this discussion.
I have some ideas about it. I guess when I think about kind of astronomy and its history in antiquity, we've always wanted to be at the center. It almost feels like human nature. We thought we were at the center of our solar system. We thought it was geocentric, and it turns out, well, the sun's at the center. We thought that it was created in perfection by some higher being, and it turns out, well, things actually aren't perfect. So then we thought, well, maybe we're not at the center of our solar system, but we could be at the center of the universe, and that's not true either. But when I think about all the different things that happen in space and all the different phenomena, there are some things that are patterned and some things that aren't. And so one example I can think of, we call it the gravitational wave background. And so if you've ever been to a lake, if a bunch of people were throwing rocks, pebbles into this lake, it's just all these ripples that are clashing and colliding and losing their structure. And if you're in a room with a lot of people and everyone's talking, it just sounds like this cacophony of noise, like there's no structure to it and there's no pattern. And so in this gravitational wave background, it's all these ripples in space from all these different sources, and it's very noisy, and it's very hard to make sense of this. And it's actually a problem in astronomy now that they're trying to be able to pull out a particular signal from that noise and from that mess. So when you say that there are things in space that don't have this organization, that's a perfect example. And if we're able to organize that chaos, then I feel like we can learn more about the system itself. And then I also think about things that are actually organized. So there's something called an orbital resonance. And so the best example we have for that are the moons of Jupiter. And so it's when you have an orbit that exerts a regular influence so that their orbits kind of align in this pattern. And so, for example, Europa orbits once, and for every time Europa orbits once, Io orbits twice, and every time Io orbits twice, Ganymede orbits 4 times. And so we call this orbital resonance because we have this pattern. And when I think about resonance in music, it's usually something that makes it sound richer. And I think when we can find these naturally occurring patterns in space, that's what makes learning about it rich in the same way.
That's cool.
Oh, cool. Go ahead.
Okay. So I don't know why, but this whole conversation about patterns makes me think about that when we look at the sky, we see the patterns of where the stars are, right? We see all the little dots in the sky, and they're always the same. There's something comforting as humans, I think, that when we look at the stars, they always look the same. The galaxy, the constellations haven't changed. And I was thinking the other day that the dots in the sky that we see that bring us comfort because they don't change, it's almost the same kind of pattern or the same feeling I feel when I see the dots on the page of music, of sheet music. There's something very comforting about opening a Chopin waltz and setting it there and knowing that it hasn't changed, between closing it and opening it, it's the same. And it's been there for, many, many, many years. And for me, because I play the piano, not a lot, but some, when I feel a little bit anxious or maybe something's off, I'm feeling out of sorts, there's something about opening that page, seeing the dots on the page, and something that happens in the process of looking at the dots and having it come out through my hands that becomes music that somehow orders something inside me. It somehow makes me feel aligned and calms me down. And after a few minutes of playing, not just playing, but actually reading music and playing it, there's a sense of order that comes into my life, which is very similar to what happens when I get out of the city to a place out in the mountains or in the country, look at the sky and you see the same stars that are always there. There's the same kind of sense of order and the same sense of belonging, because that hasn't changed, just like the music hasn't changed. So when we talked about patterns, for some reason, I went to that. That's something that I can connect with both of these topics of looking at the cosmos and music.
That's cool. Yeah.
So Eli, you're talking about the feelings that you get when you look at the sky, and Shania was talking about the order that we can find there and how order can be comforting. For me, it's just comforting to look away from our monkey world. That, you know, some people think art is all about communication and that it doesn't exist outside of our interactions with each other, and it has no meaning aside from humans. And so much art, and I'm thinking more visual art, but so much art is all about humans and their relationships with each other. But for me, the feeling of wonder and awe that I get when looking at the stars and thinking about, okay, I'm a fluid mechanicist, so, you know, the sun is this giant ball of gas, and there's interstellar gas, and nebulas, and it's all gas, and very dilute gas, but it's all gas and liquid. Yeah, so just looking at that and marveling at the physics of the world around us, to me, is the most beautiful form of art. And I appreciate humans. I mean, I love humans. Can't help that. But it's, for me, knowing that we are small in the universe, knowing that we're not the center, and that everything is going to go on just fine without us, I find that really comforting. So, there. Ties them together.
Can I talk about some balls of gas? So I brought some sounds. I'll play a couple sounds of the sun, but maybe I'll set it up and give you some context for it. Like Jean said, the sun is just this like boiling mass of plasma, and it's been likened to a bell in a sandstorm. So you can imagine, just it's getting, you know, the kind of convection effects of the heat and the boiling. It causes it to be incredibly noisy. Fortunately for us, it is both way too low for us to hear, and we're separated by this, you know, vacuum of space, so it doesn't really, you know, transmit to Earth. But with one of my projects that I've been working on, it's called the sonification of solar harmonics. I've been working with a helioseismologist from Stanford who is able to take images of the sun. They're special images called Dopplergrams, which trace either movement towards the observer or movement away from the observer. And these are recorded from a satellite that's in orbit, and it's taking pictures one every 45 seconds. So it's just this continuous you know, image of the same exact thing. But he's able to see in that and decompose it into spherical harmonics, which I'm not going to go into today because that makes me nervous to explain.
Well, the sun is throbbing.
Yeah.
That's what we're talking about.
Yeah, I mean, it really
we're
is.
going into that direction. Okay.
Yeah, okay. Yeah. So we can take these images 45 seconds after 45 seconds, day after day, collect them and put them into, just one after the next. And what we get at the end of that, I'll play you what that sounds like. And I'm gonna, just the sound folks, I'm gonna hold up a little speaker to the mic, just heads up. All right, so this is what the sun, what these images sound like from the sun without doing anything to them. Let's see if this works. So the bell in the sandstorm, right?
So you're saying they took the images and somehow they transposed the images to become sound?
Exactly. Yeah, they do. I don't want to talk about spherical harmonics. Don't make me do it, because I don't know. Somehow they're able to decompose a two-dimensional image of the sun. It has. I've seen images of it. It looks like kind of bluish and reddish. That's what it looks like, and that they're able to turn that into basically what just sounds like kind of broadband noise, right? Out of that, they're able to also run an analysis on it based on other factors. Sorry, I don't know any more than that, where they're able to within the bell in the sandstorm, pick out the most prominent, the loudest points of resonance. That we've used that word already, right? So it's like it's ringing the most, right? And so what we can do is highlight those, like isolate them, zoom in on them, whatever analogy you want to use. And also, because it's extremely low, we need to move it up so that we can hear it. So I'll play you just one of those resonances, 1 point out of what they estimate to be about 1 million resonances. So this is what that raw data now sounds like through this kind of highlighting process. So we still hear the sandstorm, but now we've focused in on one of the more prominent resonances that's happening there. I think what's interesting, I'll play one more. I feel like I'm dominating here. One short example here where you can hear a couple of them at once, because I think that's where it becomes interesting. That's where we find that resonance that you talked about, Shania, about the moons of Jupiter and having like a synchronicity where they're kind of like lining up and locking in. That's, I think, what's most interesting to helioseismologists, tells us about the kind of the behavior and the nature of the sun. So here's what I'll play for you is several of these modes coming in, I think one after the next. So you'll hear just one, and then the next, and the next. You could kind of think of that, for the musicians in the room, you can kind of think of that as the scale or a harmonic series, but it's not. It's otherworldly. Here it is. So one just thing I'll point out with that, like if you want to have a visual that goes with that, the higher the frequencies, the deeper we're listening into the core of the sun. The low frequencies propagate on the surface. So you can imagine that was sort of like diving into the sun. Yeah.
That sounded a lot like, has anybody ever heard the crystal bowls? Yeah. Right? I mean, it's like, and each crystal bowl is supposed to be aligned with a certain chakra, and it's, right? I mean, what if there is something to all these frequencies that go beyond just the sound, that actually line up to something, right? We're all connected in this universe somehow. that made me think of that. In San Miguel, where I live, a few years ago, there was some kind of an installation. There's a beautiful botanical garden, and somebody brought in this thing that they created where they put these electrodes on plants, and they somehow created, then they were connected to some kind of a synthesizer that created music. Mm-hmm. And as you walked by and touched the plant would respond or react to the touch. So in some ways, it made you realize that that plant was aware that it was being touched. So when you just walk by plants, you just pay no attention to them. They're paying attention to us at some level, right? So this reminded me of that without being a scientist, about how really probably interconnected we are, and sound is probably one of those ways that can connect us all.
Gene,
So-
I have a question for you. I don't know if is there any analogy in fluid mechanics with resonance or?
Oh, absolutely.
I'd love to hear about that.
Okay. So when you were talking about the resonances of the sun and the blue and the green, the red and the blue and the images, that's the same kind of Doppler analysis that when you get an ultrasound image of your heart, they also do that. They measure sound waves coming towards and away from you, and so what you were talking about is when I said the sun is throbbing, that's what we would call the fundamental mode. That's the whole sun expanding and contracting, okay, all at once. And that would be the lowest frequency of any resonant system. And then there would be, the next mode is when half the sun is expanding and the other half is contracting. So it's like that, or like, let's see, that. And so that would typically be an octave above. But because the sun is a big complex system, there's probably resonant frequencies in between, and you can get mixing between them. And so you can think of higher modes of vibration, where smaller parts it's broken up into smaller parts that are all vibrating. And where I find the connection to music is how human ears love certain ratios of frequencies. So the higher modes are at higher frequencies, and we hear that as a higher pitch. And so certain ratios, and I'm trying to remember what an octave is a factor of 2 in frequency. How many people knew that? Not so many. Okay, cool. All right. So an octave is a factor of 2 in frequency. And I'm trying to remember, do you know what a third or a fifth is?
So
we love thirds and fifths.
This is exactly what Pythagoras and his cult of numbers was all about, which was a ratio of an octave is 2 to 1. Like Gene said.
Yeah.
And then the next one is going to be a ratio of 2 to 3. Any guesses what interval that is? Or 3 to 2, 3 to 2. It's the next most consonant sound. So an octave, a fifth, a perfect fifth in musical language. And then the next one would be 4 to 3, which, sorry, this is not a.
That'd be the third.
It would be a perfect fourth, yeah. You're
Fourth.
on it.
Okay,
You're on
fourths.
It. What do you think the next one is? 5 to 4. Major third, major third, minor third. Yeah, so the interval size starts to collapse. And in terms of like Western philosophy of consonance versus dissonance, we go from the most consonant thing having the biggest, I should say the lowest integer or whole number ratio relationship. And as we go higher and higher and higher, we start to increase dissonance. Interest, by the way, it's more interesting.
Yes.
Consonance is boring, but yeah.
But there's something that, all humans love hearing the thirds and the fifths. What I find kind of ironic is that you can't have, in our normal 12-tone scale, you can't actually have a perfect third and a perfect fifth. And so they're fudged a little bit. That's what equal temperament is.
Yeah, perfect.
And some other cultures around the world will prioritize the third or the fifth and construct different kinds of scales. This would be called maqams in Arabic music, for example, which make you feel different when you hear them. They have maqams for different emotional states or different times of the day. So that is another one of these interesting connections between these topics.
Okay, we've got some questions here from the audience, so I'd like to start weaving in some of the questions from all of you, and feel free to raise your hand and fill out a card. This one is for Shania. Can you discuss your Astro Beats program?
I wonder who asked that question. Yeah, absolutely. So when I moved to Nashville a few years ago, I noticed that there was a very large population in the Black community, and they were not as engaged in the sciences as I had hoped. And I also know that girls at the middle school age are more prone to lose their science identity in about 6th and 7th grade. And so I wanted to think of something that was going to be fun and engaging for them to do that will also kind of build up that self-esteem and combat that issue from happening. And so I realized that everyone loves music, and that at times we kind of match our personal identities to the music that we listen to. So if I maybe got these group of girls to do something with science and music, maybe I could build back up that identity. And so I created a project called Astro Beats. And so I had a group of 8 girls convert open source NASA data into music. And so it's along the same lines of the data sonification that Seth did. And it's, we pulled data from exoplanets and from supernova explosions and from black holes. And there was a software that was called Two-Tone. And so you upload just this spreadsheet of data. And so the girls were able to assign a different key, a different tempo, an instrument, things like number of notes played per data value, so that they could create this melody made directly from real observational data. And so once they made their melody, I had them overlay that onto a background track. And so this track was something that was AI generated and that you could pick based off of your mood. So if you typed in, I'm feeling melancholy, then it would generate this music track. If you said, I feel joyful or euphoric or sad, you have a completely different song matched with some genre that you like. And so when you overlay this, you have a song that is completely personalized to the girls, but it's still based on science. And so once they had created their songs, I set up an event at the local observatory, and I brought their families there for a private event. And I hired an ensemble to perform the girls' music pieces back to them. And so they could kind of see all of this hard work brought to fruition. And it was also the first time that most of the families had been to this observatory. It was the first time that most of them had been to an observatory at all. So there was this additional benefit of bringing these families to experience this city resource. And I wanted to gauge how much the girls actually took away from the project. And so I had them take a survey before and after. And I noticed that for a few of the girls, I had them rank how much do you see yourself as a scientist on a scale from 1 to 10, 1 is being low, 10 is high. How capable do you think you are from 1 to 10? And so several of the girls came in at about a 1 or a 2, and everybody left at about a 7 or higher. And so
That's awesome.
That's awesome.
So I think when you create these kind of unique opportunities, these experiences where they can receive recognition, where they can put themselves into something and learn about something, they're going to be a lot more engaged when it comes to moving into STEM, into high school, into college, and their future careers. So I think we should always try to take something as a professor in mechanical engineering, as a filmmaker, as somebody who's a composer, and being able to take these two things that are unrelated and put them together and share them with other people.
Thank you. Yeah.
Fantastic.
Nice.
I've been attempting to use aesthetics to kind of close the gender gap in mechanical engineering and other engineering disciplines. But doing the social science of measurement of people's attitudes and what they actually end up doing, takes a long time. You have to do these longitudinal studies, and the government doesn't want to pay for it. But I do believe that this is an excellent path to pursue, that it can really, by showing the people who may not think of themselves as scientists and may think of themselves as artists, to show them these intersections and overlaps and the beauty of the synthesis. I think we can.
Yeah, absolutely. I think that marrying the arts with science and other academic areas is so crucial, because in so many schools, the arts programs have been cut. So a lot of kids don't have access to music, to art, to dance, to theater, anything like that. And so there's so much focus on just academics. Not everyone is naturally geared to those things. And when they don't have access to the arts, they don't know that they're good at something. I used to work at a place called the Institute for Arts Education in San Diego, where we developed arts programs in music and visual art and dance and all of the arts programs for kids from K through 12. And we got to see how their self-esteem grew when they realized, oh, I can write a script and I'm actually funny. I didn't know I had that skill, or, oh, I didn't know that any endeavor in the arts gave them more confidence. And what we got to see is that all of their academic scores began to increase just because of that. So in theater, which is my area, was particularly impactful. And a lot of the kids at risk of joining gangs and not even graduating from high school ended up dropping the gangs and committing to finishing high school. And that's because they discovered that they had something to give, that they were good at something through their creative expression. So since we're kind of speaking about music and something like the stars, which seems so far away, that's kind of a cool link we need to remember. Kids need to continue to have access to the arts.
Well, yeah, absolutely.
Yes.
I would just in parallel with that too, the same is true for you, citizen scientists, interested non-scientists, that these kinds of, whether it's sonifying data and making that accessible to the public, or more importantly, putting it in an artistic context or even an interactive exploratory context for non-specialists to come in and discover, like, what is this star from the South Pole, and what happens if I grab it in this VR installation and combine it, and now I'm hearing this beat that's based on the properties of its luminance or whatever. Yeah. All of a sudden, this person who had no buy-in at all with this very particular, very expensive telescope at the South Pole now is like invested emotionally and aesthetically, and I think that goes a long way to supporting science, which then supports the art. So it's a loop that connects back, and I think a really crucial piece of it is just making you, the taxpayer, aware of what your money goes towards, and that you can continue to advocate for supporting science and therefore art. Yeah.
Question from the audience. Maybe this is aimed at you, Seth. Can you talk about extreme low-frequency ELF recordings of auroras and electrical storms at high altitude and the music they make?
Oh, wow. A little bit specific.
I do like extreme low frequencies. I'm a tuba player, so. It sounds fascinating. Whoever said that, I'd love to talk with you and know what you know.
Could you repeat the question?
Here we go. Can you talk about extreme low-frequency ELF recordings of auroras and electrical storms at high altitude and the music they make?
Okay. No. Well, that makes me think of recently there have photographs of thunderstorms, and I'm not sure if that's what's being referred to here. I don't know how low frequency it is. Photographs of thunderstorms out on the horizon have shown jets emitting from the top of a thunderstorm coincident with a lightning strike from the thunderstorm. And this, it's only recently that photography has been able to capture these things. And I thought they were called elves. actually. They had some really cute names for these emissions from the tops of thunderstorms. And so I don't know who asked the question. Is that the sort? Yeah. Am I going in the right direction, or are you talking about something else?
That's cool.
Okay, all right. So you're talking about just your general low frequency sounds that are below human hearing? Oh, okay. Okay, so recordings from the radio frequency spectrum during auroras and electrical storms. Okay. Okay. Sounds like this would be another source of data for sonication. Improved sonication, bringing these low frequencies up into human hearing.
Yeah.
I know that we had a scientist here at NOAA who studied infrasound, which are the really low frequencies that happen in the Earth and in the atmosphere that are very far below what humans can hear, but they happen for example, you would be able to hear the impact of tsunami all the way around the other side of the planet, because infrasound, these very low frequencies, they go all the way. They travel great distances without dissipation. So that is something that, yeah, I think that could be raised up into the realm of human hearing and would be really interesting to create music from.
What is the neural connection between sciences and music? Why is it so many scientists also have musical backgrounds?
They have what?
Musical backgrounds.
I have noticed a lot of engineers, not a lot. There are engineers who also will try and do a double major with music. And I think it gets to some of what Shania was talking about the love of the organizational part of it, where there's a pleasure in the organizational aspects, in these relationships of rhythm and frequencies in music that engineers can appreciate, engineers and scientists can appreciate. I don't know that there's a real neurological component to that, though.
It seems like music is very mathematical, right? I mean, it's all measurements,
it can be.
And it's like,
Yeah.
you know,
It doesn't have to be, but it can be.
triplets and,
Yeah.
you know, whole notes and half notes and quarter notes and all that. I think that would appeal to engineering minds that like having that kind of specificity, measurements.
Yeah.
I think about the types of music that I listen to, and there are certain songs where, you know, there aren't any words, but it's just when the drum or something hits at the right time and I'm expecting it. I think my brain is just flooded with dopamine because I knew it was coming. I knew this was the pattern that was there. Yeah. And it's in both music and in science, you get to be creative in both cases. You get to create something. You spend a lot of your time perfecting something, and that's very rewarding.
I would just add to that the circles that I operate in are often called experimental music, and sometimes that's a little, I don't know that it lives up to its name, but at its best, like, it is an experiment. Like, the creator is proposing a hypothesis. What if I'll make something up. What if I devise a rhythmic system that's not based on dividing rhythms in twos or threes, which is typical in like most music, but let's divide it into fives, for example, right? Mm-hmm. So it's like as an hypothesis, what happens, what is the resulting rhythmic language, or whatever, and then you play that out. The difference, you know, the main difference is that the aesthetic result isn't nearly as measurable, but it doesn't mean it couldn't be. Yeah.
I have some friends who have created music based on the Fibonacci series, right? You know, it's supposed to be very natural, The Fibonacci series is what you get when you add two numbers together, they make a third number, and then you take that third number and you add it to the one smaller than it, and you get the next number. Okay, so this shows up a lot in nature. And so they made music based on it, both rhythmically and a combination of rhythmic and tonal, and it was kind of awful. I play it as a demonstration for my students, but I would never actually want to listen to it again.
If you want some good examples, because Fibonacci series is also closely related to the golden mean or the golden section, which is a ratio that is like, it's often employed in terms of proportion in music and art, and it's like kind of 2/3-ish. So you could think of like 2/3 of your way through an entire piece of music, something kind of special or important might happen. That kind of resonates with us as humans because it feels natural. It feels like a good spot for it to change. And lots of composers have experimented with that. Bartók famously, Debussy, and then certainly tons of modern composers. Probably Messiaen is probably like the most. But I'm not promising that you'll like that music any better. But those are like well-respected names anyway.
On the other hand, the visual equivalent is the rule of thirds that you may know from your camera app. You say, show me a grid, and it'll divide the image up into thirds, right? Vertical thirds and horizontal thirds. And I just read a really interesting study that if you put the subject of an image at one of those intersection points on the rule of thirds grid, that humans looking at it can perceive what that subject is more quickly, more accurately than if rule of thirds was not used in the visual composition.
Mm-hmm. Cool.
And then they were using news images, and some news images are positive and some news images are kind of negative. And what they found was if the rule of thirds was used in the composition of the image, the positiveness or the negativeness were amplified. If it was a negative image and it followed rules of third, ROT, rule of thirds, you would perceive it as more negative. And so they hypothesized based on neural processing that, human eyes take in a huge amount of information and then our brain turns around and filters it because we can't pay attention to everything all the time. So that the rule of thirds acts as one of these filter mechanisms that will make you pay more attention to things at those grid points.
I'm actually curious if in filmmaking, Eli, if there's kind of these same rules or structures that you follow to make a film elicit some type of response from the viewer.
Well, I think when we talk about composition, whether it's in film or it's in art, we talk about that, and I did interior design for a while, so where do you hang a painting on a wall? Your eye kind of wants to be on like the 2/3 of the height of the thing to feel most comfortable. Like when I walk into a room and the paintings are hung too high, I'm so uncomfortable in that space because I was like, can I just move your painting and just lower a little? So there's something that happens inherently that we're not aware of, that when something is at a certain, following those rules.
And as a short person, I'm always pissed off at the posters in my buildings are always too high on the wall. And I think, what if I was in a wheelchair, damn it?
Yeah.
Come on.
We must have some kind of inherent sense of balance, or, where things feel more aligned when those things happen, when we use those measurements.
Yeah.
So I would just push back briefly that I totally agree with that, but on the other side of the coin, like we talked about the role of like chaos in the universe, right? And so I think that's part of that Western thinking that we want to order it. We want so badly to have an ordered universe, and so maybe it's more desire than a result of natural reality. And there's so many. I just want to posit that there's so many beautiful things that are not ordered, and so many things that result from chaos that we can appreciate aesthetically. And not that a painting hung too high is good. I probably wouldn't like that either. But I think of a composer like Iannis Xenakis, who wrote this piece called Pithepracta in the 1950s. It was based on the complex behavior of gas molecules in different pressure situations, and then mapped it out visually, and then basically blueprinted it on top of music notation and wrote it for orchestra. There's not really, it's not a natural form, or it is. It actually maybe is a very natural form, but it's definitely not ordered in the ways that we've been talking about. So I just want to throw that as an alternate idea.
Yeah, but don't you think there's like a natural order in the universe? I mean, even when we look at the stars, and when you look at, somebody was mentioning the pattern of a sunflower, right? When you look at nature and you see these things that are unreal about how like mathematically ordered they are. You know what I mean?
Yeah, but at the same time, looking at constellations, that's a pretty random distribution. These stars are all over the place, and they're all at different distances, and
yet
there's a little bit of order imposed by being in a galaxy and seeing what we see from that. But I think there is something to be said for disorder and the beauty of that in our world as well.
I'd like to ask each of you if you have a cosmic connection to either the moon or the stars or the sun, and if there's a piece of music or a film or some other piece of art that brings that connection to you. Like the moon, for example. To me, my sister and I both have this connection with the moon. We send pictures back and forth, when we get this great photo of the moon. And then I think about these great films or pieces of music that talk about the moon. They must be over the moon the same way my sister and I are.
I love vortexes, and so the spiral galaxies are my favorite. I can definitely say that.
Okay. And is there a piece of music that...
Do you know about George Crumb's Spiral Galaxy from Macrocosmos, excuse me. So George Crumb's a composer from the 1960s, 70s, and you should absolutely look up that name, George Crumb, like a breadcrumb. And his musical scores are so beautiful. They come out of this super old tradition of basically not just doing boring music notation, but like designing, in this case, a spiral galaxy. It's a literal spiral of 5-line staff notation. He has other things like the Agnus Dei, which is like in this cruciform shape, and it's just anyway. You got a piece of spiral galaxy music waiting for you, Gene.
I'll check it out.
Here's a question from the audience. Do you see his astronomy work in the music Herschel composed? Does anyone know the composer Herschel?
A little bit. Sorry, I'm gonna let you down.
Sorry.
Herschel rings a bell in the history of telescope development, right?
What's the first name?
Optics.
Okay, another question. Astronauts talk about the awe of the overview effect. Does music have an equivalent uniting sense that it can create? Can we use that to build more unity here?
I feel like you could talk about that, yeah.
I know that music has been used by political movements for a long time. So it does, I self-medicate with music, right? I want to feel better, so I'll put on something cheerful, and it works. And I think I'd be worried about people using it on me.
Eli, you have a thought?
Not about that one. I kind of got stuck with the previous question you asked about the moon and the sun and all that. I think the moon is such a presence. I mean, so is the sun, but there's something mystical about the moon disappearing and coming and all that. And there's so many songs about the moon, and I just wondered if we might all sing a little song about the moon that you all know. Yeah. And I just pulled up the lyrics here so that I had it. You know it, and it's a song that I think a lot of you know. Blue moon, you saw me standing alone, without a dream in my heart, without a love of my own. Right? Everybody knows that. You instantly get this feeling from that, right? Blue moon, and what's the moon? Blue moon. Blue moon doesn't even show in the sky, right? Yeah.
Yeah,
Is the blue moon, what is it? That shows up very once in a while?
It's a fifth full moon in a month, I think.
There you go.
It's kind of arbitrary.
Yeah. There's a lot of, yeah.
Second full moon in a month.
There you go. Thanks for singing with me.
Oh, we have 5 minutes. We have 5 minutes. Any other questions? Fill out your card. And do any of you have a question for another panelist?
Well, I want to talk a little bit about the healing aspect of, because that's something that interests me so much. The healing aspect of music, and also the healing aspect that I think we've all experienced when we have an opportunity to just get lost in looking at the stars. You know, what is that? Where does that come from? You know, for me, it's all about, we're just a teeny tiny little speck in the middle of nowhere. And we worry so much and get so angry about little things like I could just blow up because my internet is slow, right? And then here I am in the middle of this vast universe. My husband and I always say to each other, you know, and he reminds me a lot when I get upset about things, how does this look from the moon? Okay. If you can see it from the moon, then worry about it. If you can't see it from the moon, then it's okay. It's going to pass, right? But the healing aspect of who we are and where we belong and all this stuff we worry about human beings, and we're just a little grain, a tiny little speck floating in the middle of nowhere. We don't even know if there's life somewhere else, and yet let's keep it in perspective. Yes, we need to heal some of those things, but how do we connect to the bigger nature of the universe and really connect to that, knowing we belong to all of that, even if sometimes it doesn't feel like it, and how as humans we create music that can be so healing at the same time, you know, through the talent of just who we are as humans. So I think there's a huge aspect of healing that we can connect both of these things with.
Thank you, Eli. And if each of you would just take 1 minute with the final thought, that would be great.
I just want to remind everyone that we can all be artists in whatever medium we choose. Actually, let me ask, how many people in the audience identify as artists? Yay! All right.
Awesome.
And how many identify as, you know, kind of a more science, engineering, geeky? Okay. All right. Good. How many see themselves as both? Yes. All right. Thank you.
Awesome.
That's something we can all strive for.
I guess I would just say you should always take time out of your day, your week to try and be creative because it's very fulfilling. And so an exercise I like to do is I will think of my favorite hobby, or you should think of your favorite hobby. It could be archery or collecting records or maybe like hiking. And then I try to think of what's the topic of interest to me at the moment. And it could be something broad. Maybe it's biology or economics or history. And then the harder thing to do is to think of how can you merge those two things. And sometimes you might already have something in mind, but sometimes you might have to really think on it. These are two things that might seem unrelated, but you can always connect them somehow. And so it gets you thinking in this interdisciplinary way. And I try to do that every so often, so I think it's a good practice to do. And I loved hearing the songs from Seth, so if I didn't bring any clips, but if you wanted to hear the songs that the girls made, you can go to astrobeats.us and check them out. astrobeats.us.
Great.
Yeah, that's very cool. They sound great too. I listened to them earlier. I don't know if I have a closing thought necessarily. I think, you know, I'm a musician. That's what I think about most of the time. And I work with musicians. I'm a teacher, so I work with college-age musicians. And I think one of the things that I am constantly hoping for my students, and I think that it has some parallels here, which is that their conception of music and art, by extension, expands beyond where it is. And I hope that for myself too. You know, we all have our limits of what we think art or music is, but I firmly believe it's alive and active and changing and progressing. And I think that these avenues that we've discussed with looking outside ourselves and outside of human art as a reference point, but instead to the natural world in various capacities as inspiration, or perhaps like direct, telling me what to write. I think it begins to crack open that shell that we put on what we think is good and art and what we can do. I think I hope that for my students. I hope that for every one of you too in your listening habits. So, yeah.
Well, let's have a round of applause for this panel. And thank you all for coming. And Eli would like to close this session.
Thank you. I'm like, they skipped me, but I just want to remind everyone, and me too, I remind myself of this all the time. There is a natural order of balance in the universe, and sometimes the pendulum swings all the way to the right, and then it swings all the way to the left in trying to attain that balance. And the further we go constantly like this, that's where we have all this chaos. Balance is really in the center, and eventually, I believe, we can come back to that center. So just know that wherever we happen to be, especially what's going on in our world right now, it seems like the pendulum's swinging so far away. It's only temporary. It will swing back the other way, and eventually, I believe, we're going to find balance. Yeah.
Thank you, Eli. Thanks, everyone.